4.2, second derivative and graphs. This is the second derivative test. In 4.1, we did the first derivative test. They're very similar. We just have some different concepts, and we have to take the derivative twice in order to get the second derivative. So let's take a look at the example, and then we'll make some of the connections. So in our first example, we have find the intervals on which the graph of f is concave upward, concave downward, and the inflection points. Okay, well, concave upward would look like this on the graph, and concave downward would look like this on the graph. Okay, the inflection points is where the concavity changes. So where it changes from either concave upward to concave downward, or concave downward to concave upward. So we're going to be finding these things out. And the second derivative tells us where it's concave upward and concave downward. If the second derivative is positive, that's where the original function is concave upward. If the second derivative is negative, that's where the original function is concave downward. And we can also figure out where the inflection points are by setting the second derivative equal to 0. Okay, so very similar to what we did with the first derivative test. We just had to take the first derivative. So in our first one, it says f of x equals x to the fourth plus 6x squared. Let's go ahead and start by taking the derivative. So we get 4x cubed plus 12x. Well, but we need the second derivative. All we have to do is take the derivative again to get the second derivative. And notice it's represented with two little primes up here. So we've got 12x squared plus 12. So you could keep taking the derivative over and over and over again and keep getting like the third derivative, the fourth derivative, and so on. Sometimes the derivative ends. You can't take the derivative any longer, but sometimes you can keep going. So, you know, however many times you need to take the derivative. In this class, we're only going to have to need to take the second derivative. All right, well, we'll set the second derivative equal to 0. So we get 12x squared equals negative 12. Divide by 12. Okay, well, when we take the square root of both sides, we're seeing that we're taking the square root of a negative number. So again, this one's going to have imaginary numbers. Well, remember what that meant when we got one like this in 4.1. It just meant that there are going to be no inflection points in this case. Okay, in the last section it was no critical values, but here we've got no inflection points. But you can see if the graph is entirely concave upward or entirely concave downward. Okay, so you're going to just pick any value you want and plug it into your second derivative. So I'm going to pick 0. And we get 12 times 0 squared plus 12. So it gives me a positive 12. Okay, so it gave me a positive number. That means it's concave upward for all. Let's try another one. Part B, f of x equals negative x to the fourth plus 12x cubed minus 12x plus 24. The first step is to take the second derivative. So we'll start by taking the first derivative. So we've got negative 4x cubed plus 36 x squared minus 12, and then we'll take the derivative again. So we get negative 12 x squared plus 72 x, and then we'll set our second derivative equal to 0 to find our inflection points. Well, I see that I can take out a negative 12x, and that'll leave me with an x minus 6. Okay, so set both of our factors equal to 0 and solve. So we get x equals 0 and x equals 6. Okay, well, just like the last section, when you actually get some inflection points, or in the last section they were critical values, we put them on a number line so we can see what our test intervals are. And we need to pick something less than 0. We need to pick something in between 0 and 6. And we need to pick something greater than 6. Okay, and just like last time, I already picked out my values. So I picked out negative 1. And you're plugging it in to your second derivative. Okay, so let me make sure that was still on the screen. Yes, it is. Okay, so plug your negative 1 into your second derivative, and I got negative 84. Okay, that means it's concave downward for that interval. All right, I plugged in 1 and got 60. Notice I didn't plug in 0 this time because 0 was one of our inflection points. You don't plug in the inflection points. You'd get 0 for the answer because that's what we set the second derivative equal to. Okay, so you want to pick something inside each of the intervals. Okay, so this interval right here is concave upward. And then finally I plugged in 7 and got negative 84. So that last interval is concave downward. So let me write out our answer. So I'm just going to put CD for concave downward. So from negative infinity to 0, (6) to infinity, concave upward, 0 to 6, and our inflection points at x equals 0 and x equals 6. So take a look at the notes because it does go through some more of the definitions, and try out the homework.